Good day everyone, this is Nerichem. Question 2. Which row of the table correctly matches the chemical additive with its main function in a water treatment plant? Chlorine. Chlorine is a halogen, Cl2. And chlorine is a oxidant, which means that it can indeed kill microorganisms. So, fortunately, we've already found the answer to the question, but in the interest of science, we might describe how chlorine kills microorganisms. Chlorine causes oxidative damage to the cell membranes. Oxidative damage. When the cell wall is damaged, we cause an increase in cell permeability, and the chlorine can also damage the DNA inside of the cell. This is how the mechanism of action, or MOA, is established for chlorine. Fluoride, reduce turbidity. So fluoride is F-. It is a halogen anion, and fluoride is indeed an additive in water for drinking. However, it doesn't reduce turbidity, rather it is added to strengthen tooth enamel. Now, tooth enamel is made of hydroxyapatite. Of course, this is not apatite in the sense of I'm hungry, which would be APE. This is apatite, APA, so apatite. Now, the chemical formula for hydroxyapatite is 10 calciums with 6 phosphate anions and 2 hydroxyl anions. Now, the mathematics for this chemical formula is slightly more complicated than what we're usually used to. Phosphoric acid is H3PO4, so you know that the phosphate anion is 3-. So 3 times 6 would give you 18 negative charges, plus 2 single negative charges from the hydroxyl anion gives you 20 negative charges. We know that calcium is a dication, so it's 2 times 10, plus 20 charges, it's overall neutral. However, I wouldn't commit the mistake of thinking that calcium hydroxyapatite is this chemical formula here. This is just the ratio of ions inside of the crystal, because it is in fact a mineral. If anyone has ever tapped on their teeth, they can immediately find out that it is indeed a crystal mineral, which is quite hard. What happens with the fluoride is that it substitutes these hydroxyl anions, and fluoroapatite is actually more resistant to acids, and it is less soluble than hydroxyapatite, which is why it is added to our drinking water, and it does not reduce turbidity. Just as a fun fact, the additive which corresponds with reducing turbidity would be a flocculant or a coagulant. Now, a flocculant would be, for example, alum, and a flocculant destabilizes suspended charged particles. So if you have water which contains a lot of suspended particles, for example, we may think of our swimming pools, which do not look clear. When we add a flocculant, they are destabilized, which means they agglomerate together, which is a fancy word of saying they clump together, sink to the bottom, and then you can filter the solids out of a turbid water source. Now, C says iron 3+ minimizes tooth decay. As we already described in part B, we know that fluoride minimizes tooth decay because it produces a substitution, creating fluorapatite, which strengthens our tooth enamel. In fact, I don't think that iron 3 plus even is a drinking water additive. If it were to be an additive, I would imagine that it would just be for nutritional purposes. But iron, in fact, has 0.3. So this is part C. Let's draw an arrow just to make sure. Iron has a 0.3 milligram per liter drinking water concentration limit as established by the World Health Organization, or the WHO. And in fact, iron causes staining in clothes. So if you use water which has a high iron concentration, it would stain your clothes. And also water which contains high amounts of iron smells different and perhaps not as pleasant. So probably the least likely candidate for a additive on this list. Finally, we have the easiest part of this entire question, which is almost offensive. We have that hydrochloric acid increases the pH of water. We know that increased pHs are basic or alkaline, and we know that hydrochloric acid, as the name suggests, is an acid. Therefore, it would in any case decrease the pH of the water if it were an additive. So thank you very much for your attention, and I hope to see you next time. Goodbye.